Assalamualaikum and hi everyone. My name is Asfa Adelina binti Faiza. I'm from City to OSIT. In this video, I will explain regarding the project titled UPTM Marketing Optimization, or we call it as MCOP. Okay, basically the main objective of this project, we want to find the shortest path and the most efficient routes for visiting all cities that start and end at UPTM. And in this project, we also implement different approach in terms of its algorithm. This UPTM marketing optimization, or MCOP, kind of similar to TSP, which is travel salesman problem, and we can include that problem into this project because it's kind of similar to what we are going to solve. Alright, without further ado, I will walk you through UPTM Marketing Optimization Program. So as you can see on the screen, we have this project in BlueJ. I use BlueJ to write all the code. So UPTM Marketing Optimization, like I will click this. Okay, so it will show you all the algorithms that I apply and also the cost metric. So we are going to take a look at this code or block of code one by one. So before we start, the first thing that we need to insert is the cost metric and its location. This is the input data for all algorithms, which is we are going to use this cost metric for all algorithm or different approach. And each element's cost metric, like this, represent the distance cost from CTI to CTJ, while the location, it stores the names of the cities for display. Okay, as you can see in this one is a cost metric, and this is the locations that we want to store, which is the names of the city. Alright, after we already insert all the cost metric and the location into the program, we are going to start by using greedy algorithm. So greedy approach, it's always move to the nearest unvisited city. The pros of using greedy algorithm, it gives you a fast output and simple, while the cons of using greedy algorithm, it may not always give an optimal route. So okay, this is the whole code of greedy algorithm. Okay, we are going to take a look at this first. Okay, total number of cities, I use this statement, and to track which city have been visited, I use boolean, and to start at UPTM, I use int current 0. Same goes for total cost. Okay, to track total travel cost, and this stream view the road and new stream view the location current is to store the road as string. And for visited and the current equals to true, it's to mark starting city visited. So the city that you have been visited, it will mark it as true in this code. So for repeat each city, I use iteration. Okay, and to find the nearest unvisited city also, I use this. And then we move to the next city, I use this statement. Okay, and mark as visited, add cost to total, and update current city. Then we'll return to starting city, because that's the main objective of this project. We want to start and return back to UPTM. So that's why I use total cost and then this statement. And then it will return greedy road and then the total road that you have been visited, and then it will end at UPTM. Also, it will give you an output for total cost. Okay, so that's for greedy algorithm. Okay, but basically in code, we start at UPTM, find the closest unvisited city in a loop, update the route and total cost, and finally return to UPTM. So that's for the greedy algorithm. Okay, moving on to the dynamic programming. Okay, dynamic programming, it uses memoization and bit masking to find the exact shortest path. And the pros of using dynamic programming, it gives you an exact solution, while the cost lower for large number of city. What does it mean for slower for large number of city? In this example or in this project, we just use 4 different city, right? UPTM, CTB, CTC, and CTD. But if you use more than that, it will give you it's not like it will give you a slower output, but it will slow the process of for it to execute. Okay, so that's the cons of using dynamics programming. But in this project, we just going to use it because it's only 4 cities that we are going to use. Alright, so for this bit mask is for all city visited. Store minimum cost for each state, we use in Memor. Store net city for road reconstruction, I use this. Okay, and then we need to initialize memoization area with -1, which is not computed yet, like in this statement. And then we need to compute minimal cost starting from CT0. Then we need to reconstruct the optimal route using the path array like this. Okay, just starting with CT0 visited and then starting with CT in next. Okay, and then for visited, which is while visited all, mark net city visited. Okay, this is to mark the net city visit. Okay, so it will return dynamic programming roads. Okay, this is the city that you have been visited, and then end at UPTM and the total cost output. Okay, so for dynamic program, it store minimum cost in memo and reconstruct the routes with paths, and it uses memoization and bit masking like I just explained in previous video just now. So that's all for dynamic programming. Okay, next we use backtracking algorithm. For backtracking algorithm, it recursively try all possible routes to find optimal path. So the pros of using backtracking, you get the exact solution, and the cons are very slow for large number of CT. Same goes for dynamic programming cons, right? Okay, so this is the code, the block of code. Okay. So we start at UPTM, and then we store best cost file, and then store best route. Okay, and then we start recursive exploration, and then backtracking routes. It return backtracking routes. This is the output, and then this one is for all cities visited at cost to return to start, and then we update best route. Okay, and then it will return. Right, this code, okay, is to explore all unvisited city recursively. So it will like break down until the simple form. Okay, so that's backtracking algorithm. Alright, and then moving on to the divide and conquer. Divide and conquer, it recursive nearest neighbor selection. The pros of using divide and conquer is simple and fast. For cons of using divide and conquer, it may approximate. What does it mean by approximate? Alright, so approximate may not find the optimal route. So that's the cons of using divide and conquer. Right? So it will recursive nearest neighbor selection. Okay. This is the base case. And then find nearest unvisited city. Then we use backtrack for other branches. So now we will return. It will return true. Okay. So this is for divide and conquer. Alright. So moving on to the sorting and searching algorithm. In search and sort, sorts the array in ascending order. So the loop start from second element, index 1. So for index 1 is second element, while the first element, which is index 0. So that's the difference between index and the element. Okay, and then we include current elements to be inserted, and then we start comparing with previous element. After that, we need to shift the elements that are greater than the key to one position ahead, and then we place key in its correct position. Okay, that's for insertion sort. While binary search, it searches for a target value in a sorted array. So we define search boundaries first, and then we continue searching while range is valid. So find the middle index, target found, search in right half and left half, and then target not found. So sorting and searching, which is insertion, sort, binary search. Sorting or searching might be used to organize cities, costs, or other related data during the optimization. But for MCOP, they support efficient handling of data in the program. Which is min heap and splay tree. For min heap, it using Java priority queue, which is smallest elements always at top, while splay tree, self-adjusting binary search tree. So for min heap, min heap helps in efficiently selecting the next city with the lowest cost. Usually useful for greedy approaches, while splay tree speeds up repeated access to frequently visited cities or costs. But basically, both of these show practical ways to improve algorithm efficiently, which is really important in MCOP for large data set. Okay, so yeah, min heap and then splay tree, which is include all the root. Okay, after that we also have the main function. Okay, the main function is to running all the algorithm, okay, that we already write in the code, and then it will give you an output. Okay, so now let's compile this file first. Okay, and then show the output. Okay, this is true. So that's the output of all algorithm that we use in this project. So as you can see, everything matched with the objective. So yeah, that's all for this video.